Hello, my friends. Today I'm going to talk a little bit about geometry, not the typical geometry you learn in high school, but a different kind of a geometry. In high school, you often learn that the three angles of a triangle add up to 180 degrees. However, today I'm going to show you a case that's quite different. That is the case when you move outside of the paper, the flat paper. You move into the world of spheres. So, right here on this board, I have a picture of a sphere. As you can see on the picture here, I have a triangle drawn on the sphere. The top, as you could see, is think of this as the Earth. We have the North Pole, this top portion. We have the equator, and we have two latitudes, as you could see. So we formed a triangle here made out of the top North Pole, two latitudes, and the equator. As you could see from the picture, we have three angles that are all three 90-degree angles. That's very weird. You're not used to that. If you add up the three angles, you get 270 degrees. So often people ask me that, okay, on a piece of paper I have a line, but this doesn't look like a line. Okay, this does not look like a line. It turns out that in high school you learn that the line is the closest distance between 2 points. On a piece of paper, it looks like your typical line. However, on a sphere, 2 points, the closest distance between 2 points, is not necessarily a line. You're not allowed to penetrate through this sphere. So as a result, you get this curve here. That's actually, you could prove that this is part of a circle. Now, I want to bring you to a totally different subject, the subject of optics here. Let's now move to this part of the board. As you could see, I have a picture of a convex mirror. This is a convex mirror. We have a person standing in front of the mirror, and this is the distorted image of that person. You might be familiar with this equation, 1 over p plus 1 over q equals 1 over f if you've had high school physics or college physics. This relationship tells you the relationship between the distance of the person, the observer, from the mirror, that's p, the distance between the image and the mirror, that's q, and f is the focal point. The focal point, by definition, is the point where all these rays of light start converging. So that's the focal point. So as you could see from this equation, we have a nonlinear relationship between P and Q. So your image gets distorted in a convex mirror. Now, the reason I brought this up is that in mathematics, you often see people who are not necessarily mathematicians coming up with great discoveries. One of these people is a German scientist, or a German physician actually, a doctor, a medical doctor by the name of Hermann von Helmholtz, the great German medical doctor who was very interested in knowing how the eye works. So in order to study the eye, he realized that he needed some physics. And in order to understand physics, he needed geometry. Therefore, he was one of the key contributors to the idea of non-Euclidean geometry, the geometry that's on surfaces like this sphere that I have on the back. So I wanted to kind of let you know that this geometry is a little bit different from our typical geometry. So think of this as a geometry on a convex mirror. So I have here a spoon. You could use a spoon as a convex mirror. You could see your reflection on this part of the spoon. So use this to see how this geometry would look like. So in this type of a geometry, as I mentioned before, the three angles of a triangle add up to more than 180. The larger the triangle, the larger the sum of the angles become. So due to the respect I have for Dr. Helmholtz, I borrowed 3 volumes of his most important work from the library. As you could see, this is the 3 volumes. I borrowed this from the library. 3 really big volumes on physiological optics. Okay, let's browse through these books. Okay, I have the first volume here. Let's take a look inside. Here we have a picture of the great Helmholtz, the great 19th century doctor who became a physicist and one of the greatest mathematicians of the 19th century as well. So typical 19th century scientists, you could see, back then they were, older people with mustache or beards. And you could browse through this book. Lots of interesting stuff in this book. Okay, how lenses work, how the eye works, and the laws of optical imagery. And probably the favorite volume, my favorite volume, is the 3rd volume. The 3rd volume has a section on the movement of the eye. You could see there's lots of mathematics, spherical geometry, lots of mechanics. So as you could see, someone who was initially a doctor became one of the leading physicists and mathematicians of the day. If you're familiar with, if you've been probably to an eye doctor, they have a device called a ophthalmoscope. That's a device that was actually invented by no other than Hermann von Helmholtz. Okay, so I wanted to share this video for you. Hopefully next time we're gonna go over more stuff related to mathematics in general. Thank you very much.